I'll just start recording. Okay, so everyone can see the PowerPoint, I hope. What we'll do is, if anyone has any questions, while we've still only got 2 people that aren't library staff. Oh, there you go. Yeah, while we've only got 2 people that aren't library staff, if you've got any questions, fire away. Ideally, they will hold questions off until the end of the session, and we'll see how we're going for time. Anyway, I'm Troy. This is going to be a strange experience for everyone, or for me anyway. And what we're going to be looking at today is metrics and benchmarking for science HDR students. And what we're going to cover is what are metrics and what they can be used for, the 3 varieties of metrics, how these then apply to your work and how you can improve your ranking and just make your numbers look better. We'll have a look at some of the popular metrics and some things to consider when you're using those metrics in grant applications, in job applications, or however you choose to use your metrics. And some things that you can do if they aren't as good as you'd like them to be. And right at the end, we'll look at some of the benchmarking stuff that we can do for you within the library. So before we get firing, video panel. So what the very first steps that you should do as HDR students or early career researchers or even mid-career researchers are to create an ORCID ID. Pretty much every article submission that you do these days requires you to have an ORCID. If you don't have an ORCID, you know, you don't get published. I recently had a paper published in a chemistry journal, and part of that was that I needed to have an ORCID ID. If you don't have one, create one. And then you want to link that to your Scopus profile and your Web of Science profile. When you've got those 2 things set up, you can create, you can curate your author profile. So any papers that get published get connected to your Scopus ID and to your Web of Science ID. And then if they're connected up to your ORCID ID, everything is in a central location. Everything is correctly attributed to you. And it's really easy to get things into RMS from ORCID. It's good to be on top of your profile and make sure that that everything that you've done is correctly attributed to you. By doing that, then all of your numbers will appear in the correct places. The other thing that you want to do is to publish strategically. So within Scopus, there's a journal source list that you can look at, which is basically a list of journals that publish within a subject area. It's purely based on their assigning of a journal to a subject area. It's not the be all and end all of the best titles. It's just the ones that have got the best number in the broader categories. So the advice that we would give to you in this case is to use the journal list from Scopus, use your subject area expertise, and then choose the titles that sort of meet all the criteria that you're after. Okay, so that's that. And the other thing, I'll make this PowerPoint available along with the recording of this session after this is all done. Anyway, what are metrics and how are they useful? They're basically just a way of measuring aspects of your scholarly output. There's the straight just counts. So an article has been cited a certain amount of times. And then there are the ones that involve calculations and various normalization being applied to them. Probably the most common one that you'd see is the field-weighted citation impact, which takes the subject area, takes the citations, takes the time, throws it all into a pot, gives it a stir, and then gives you a number. Basically, 1 is the standard for anything that's been normalized. So in the case of the field-weighted citation impact value, a score here of 2.08 is twice as good as an average article. Ideally, you want everything that you write to be, 1 or better. All metrics are then used to rank authors, articles, and journals, and it's important to choose the best metric to highlight your work. Some of your material will have a good metric, will have out of all the metrics that are applied to it, some of them will be good, some of them won't. Sometimes weird things happen with the databases as well. You may go into it one day and see that it has a particular value of whatever that value is, and then you go into it a week or two later and it's changed substantially. It's all, weird things happen every now and again. Anyway. So the tools that are used to discover metrics, the traditional metrics, so the ones that we'll focus on primarily in this session, are derived from 2 main platforms. There's the Scopus and the Web of Science camps. So Scopus and SciVal are one set of tools, and Web of Science and Insights are the other set of tools. These are for author and article-based metrics. You can access all this stuff from the library homepage. If you go from the library homepage onto databases, and then we've got Scopus under S. You've got Scopus here and SciVal, and Web of Science is obviously just under W. I much prefer searching Scopus. I just prefer to use it. It works, it does everything nicely. And if you haven't used Scopus before, this is what it looks like. The journal sources list, we'll go into that a little bit later, but that's under here. If you don't have an account, just create an account. If you do have one, you just sign in. And then you can access everything there. They have recently modified the way to access this database through the institutional login. So if you're having any issues logging in, just click on the institutions icon, choose University of Sydney, and away you go. Righto. The other type of metric which is increasingly or becoming increasingly prevalent or prominent is alt metrics. These are basically everything that isn't a traditional metric. Can be things from Twitter mentions, from Wikipedia entries, newspaper article mentions, Mendeley library ads, downloads, views, anything else. The value of them is potentially questionable, but if you have a good altmetric score for a particular piece of work or a set of pieces of work, it is certainly worth or potentially worth mentioning it. There is a product that the library has access to. I think we subscribe to it. It's called Dimensions. It kind of feeds in from altmetric.com. I think that's the website, and it's a good way to find your altmetrics data as well. So again, under databases, dimensions, that's it there. And yeah, so this one, if you wanted to find yourself, it's just under researcher, and then expand it, and you put in your name. Oops, I've accidentally pressed something else there, but you can see here, this particular paper has an altmetric score of 2, and there are 4 Twitter mentions. You can click onto that and see the tweets if that excites you. Okay, that's about enough of dimensions. Now, what types of metrics are there? There are 3 general varieties. There's the author level metrics, So there are your counts of how many papers you've written, your overall citation count, your H-index. There's article level metrics. So again, it's citation counts and field weighted citation impact figures. And then there are journal and publication level counts. So that's the impact factor of the journal, citation rates, all that sort of stuff. Most metrics apply across multiple areas and they all feed into each other. Obviously, an article can't exist without an author, a journal can't exist without articles. They're all intertwined and linked. So author level metrics, they assign bibliometric values to an author and their work. The main ones that you'll see in here are the H-index. So that is how many articles you have that have been cited at least the same amount of times. If I've got 10 papers and 4 have been cited 4 times, I have a H-index score of 4. The main downside of the H-index is that it favors people who've been around for longer. The longer an article has been available, the more opportunity it's had to be cited. So if I'm an academic that has been writing for 20 years and I've got 200 papers and 35 of them have been cited 35 times, but it was all back in the 80s, I have a H-index of 35. One thing that I've seen increasing is the H5 index, so it's only looking at papers from the last 5 years. Some grants, particularly NHMRC, they don't accept H-index values as a part of the application. So just be wary of the H-index, and each platform generates a different H-index score. Google Scholar will give you one that's about 10 times higher than what you'll get with Scopus or Web of Science. Scopus is a bigger database than Web of Science, so depending on your subject area, you may have a H-index score of 1 or 2 scores higher than what you get in Scopus. The other one here is a normalized value, the field-weighted citation impact score. It's a ratio of citations that are received by the author or the paper relative to the expected amount of citations. One's the average, higher is better. The aim of it is to normalize the score of each paper so that you can compare apples and oranges. It's influenced by time, so you need to be aware of that. If you look at the score of a paper that you've written, say 12 months ago, and it has a field-weighted citation score of 3, in another 12 months' time, it could go down to 2 or it could go up to 4. It can change depending on the citation rate over time. Another measure for authors is the citations per publication. That's just an average of the citations across your total output. This one can be impacted by, recently Scopus has started to include conference papers, and Web of Science has as well. An increasing amount of conference papers have been sort of added in the last 6 to 12 months, I've been noticing. Conference papers don't really get cited as much, so what I've been observing is people's citations per publication count going down as the amount of papers coming in is increasing, and it dilutes the pool. You can exclude conference papers when you're calculating this figure. The whole point of metrics is to basically tease out the good numbers that will support your applications. And yeah, if you have a couple of papers in Nature or Science or any of the big titles, that will obviously get cited more than something in a small regional journal on a very niche topic. So they're all just things that you need to consider when you're using that figure. Another one that is useful is the outputs in top percentiles in most cited journals. I thought I'd put that in there, but I didn't. That one is a straightforward metric that draws upon author and journal level metrics and it represents the amount of articles you have that are in the top 1, 5, 10, or 25% of journals in a subject area. ERA reporting uses the top 10% of figures. I've had requests from people previously asking for the ratio of their papers that are in the top 1 or the top 5% of journals within a particular FOR code. It's an easy number to pull out, and you can get that out of SciVal. And another one that's useful, particularly with job applications, is international collaboration. So how many articles you've written with people that are from another country or another institution. Okay, article level metrics. These are quite closely related to author level metrics, and they feed both author and journal ones. The main ones here, again, are citation count. So it varies from platform to platform. Google Scholar doesn't have any sort of vetting or sort of maintenance of the records. So you end up with a potentially much higher citation count for your article there. But it's fairly reasonable, a fairly reasonable number to pull out of Web of Science and out of Scopus. It will only count citations that are found from within that database though. So if you're publishing in a journal that is, or if you're being cited by someone that's publishing in a journal that is not indexed within Scopus or Web of Science, that count will go down. We'll have a quick look at the end at the reports that the library can provide, and I'll show you where we have the citation count there. Again, we've got the field weighted citation impact. It's exactly the same as the author one, except it's assigned on an article level. So it's an expected amount of citations that the article should have based on the time and the subject area, and it assigns a number. We get that out of Scopus. The citation benchmarking percentile, that is data again from Scopus. It's similar to the field weighted citation impact. It looks at the article, it ranks the article, sorry, against other articles within the discipline. And then it assigns a subject area against it. It's calculated based on the last 18 months worth of citations that the paper has received. Again, just as a sort of way to keep it current, keep it just looking at the most recent material. Okay, and the last one, the last grouping of metrics are journal level metrics. Funnily enough, these assign values to a journal. The main ones here are the ranking tools. So there's the Scimago journal rank, the journal impact factor, and site score. These are just ways to rank journals within a subject area. Scimago looks at the, it's an index based on the prestige of a journal. It's an attempt to rank the journal, or recognize, sorry, that the journal and subject areas have lower citation rates than other subject areas. And it kind of just tries to assign a score based on a complex algorithm that they have in the back end. The journal impact factor uses Web of Science insights data. It does a similar thing to SJR, but it uses the citation impact. It's not normalized data, however, so you can only really use it to compare titles within the same subject area. Site score is Scopus-driven data. It looks at the citation rate, the average number of citations in each year over the past 3 years. And again, it just tries to rank the journal within a subject area. With those three tools, if you're looking at publishing in a particular journal, again, always look for the one with the biggest number, the highest number. And the site score one, you can look at it for each year, and you can actually, with both SJR and journal impact factor, I'm pretty sure, go back in time and see the performance of the journal over the last 3-4 years. if you're trying to select a title to publish in, you probably want to look for one that's improving or steady, not one that's dropping in its ranking. For whatever reason, some journals, they tend to fall off a bit of a cliff sometimes. And the other type of metric that gets assigned to journals are the article-derived indicators. So they're the SNP, the source normalized impact per paper value, the citation count, and the H-index. So the H-index is exactly the same as for the author, except it's at a journal level. The citation count is just that. It's a count of citations in the year across all the articles that are published within that particular journal. And the SNP is, it's the ratio of the average citation count per paper and then the citation potential for the subject area. Again, this is normalized data, so you can compare different subject areas. Yeah, when I say that it's the subject areas with the normalization, it's this is what's decided by the database platform, by Scopus or Web of Science or anything like that. It's not necessarily what you would be putting into ERA or into IRMA or anything. So you just need to be aware of that. Okay, and when we have a look at the journal list, I'll show you some other stuff. So what metrics should I be using? It all depends on what you're after and certainly on what numbers look the best. If you're going for a grant or promotion, you want to be looking at the author and article metrics. If you're looking for a particular journal to be publishing in, you're going to be looking at the journal metrics. Okay, that's just a brief table there. If the numbers aren't good, don't stress about it. Don't worry too much. Find the best number out of all the numbers that we'll give you when we run a benchmarking report for you, a metrics report for you. Choose the best ones and highlight that. No one's metrics report looks amazing all the way through. Everyone's got a few things that are a bit down on what you would expect. So don't worry about, bad numbers. And you can't see, but I just put bad in air quotes. Anyway, good decisions early on. What you want to do after you've set up your Scopus ID, your Web of Science ID, your ORCID, you've linked everything. What you want to do in your first couple of articles is to publish in the most highly ranked journals that you can possibly publish in. In a perfect world, every paper you publish would be in Science, Nature, in all those top ranked journals. Obviously, that's not going to happen. So you want to publish in the highest ranked journal that you can, the journal that has the highest citation count, and the journal that has the highest percentage cited rate. We'll have a look at the source list in a moment, and I'll show you where you can find those numbers out. The percentage cited rate is how many articles within a year in that journal have been cited, and the citation count is how many times the articles have been cited. Those two together can help you to pick a title where you've got a higher chance of being cited. It's a more impactful journal, and it's, they're the ones that you need to be looking, or they're the ones that you would like to be looking towards publishing in. This is that list that I've been mentioning on and off, and we'll have a look at that right now. And the other thing that you need to do is to make sure that the journal that you're looking at publishing in is actually indexed within Scopus and within Web of Science, and make sure that it's current in being indexed in Web of Science and in Scopus. I've done reports for people who have published in journals that aren't indexed in those databases. They're smaller journals, but they've had 20, 30 sites on that article. It's not indexed in those databases. We can't really use that when we're preparing a report for the researcher. It's kind of a bit of a shame. It's not a wasted article, but from a purely metrics perspective, it is a bit wasted. Anyway, in Scopus, so search is where it defaults to. The one that we're going to look at though is sources. And this is just the journal list. So we can see here that there are 41,000 titles within Scopus. You can look at a particular title if you want, or a publisher, the ISSN, or go in by the subject area. You can browse through the list and choose a particular subject area if you want, or you can type in whatever you're after. I'm just going to choose geology. Okay, so there are 353 journals that Scopus has assigned to the subject area of geology. Let's move that out of the way. And so these numbers are all site score based. It does provide the Scimago journal ranking figure. And I can go back in time and track how the journal has been performing. Site score, as I mentioned earlier, looks at the last 3 years of data. So if I'm looking at 2015, that's going to be analysing data from 2012 to 2014. We'll leave it on 2018 though. And you can see, we'll just look at the first one here. So you've got the title, the site score for the journal, the percentile, and the subject area that's then assigned by Scopus to this title. It will have more subject areas assigned to it. If we just bring up the full record, here you can see, where am I going? Over here. So these are the subject areas. It's got soil science, geology, and computers in earth sciences. Okay, so don't be alarmed when you see that we've searched for geology, but the top record is soil science. It gives me the citation count for all articles that were published in 2018 across every issue of Remote Sensing of the Environment. That's the amount of articles that were published in the 3 years prior, so 2015, 16, and 17. That's the percentage of articles that were cited, so 96. I've got my SNP score and my SJR score and the publisher. So if you have, ethical issues with publishing in a particular or with a particular publisher, or you want to publish with a particular publisher, you can go through the publisher list. You can sort it by any of these column headers as well. But yeah, if we look through just the first 5, they've all got fairly high citation percentage cited rates. Something like Geochemical Perspectives is clearly quite a niche journal. There's only 7 papers published. So I'd say that is a kind of a book series. But you can just get an idea from looking through it here at, what titles are having higher citation hit rates, and, whether I've got a reasonable chance of getting published or not. So the ones that have got, a couple of 100 papers, you're more likely to, get through in there, or perhaps more likely to get through in there, to get published in there. And with the citation count, 7% out of 650 papers didn't get cited. You don't really want to be one of them, but someone has to be. Anyway, that's the journal list. Now, if I wanted to publish in a particular journal and I just want to make sure that it's indexed within Scopus, I can put in the title of the journal. So, and it suggests that. I have never had anything to do with dentistry, but I can see here that this is my dentistry. It's a dentistry title. It's in a fairly high percentile, so it's in the top 5th of general dentistry titles. It's that straightforward to go through. to find it. The other way, of course, to find out if your journal is indexed in Scopus or Web of Science is to search for the title itself. So if we search for Australian geographer, okay, and 1,500 titles. It's current. It's being indexed in this journal. Okay, in this database. Sorry. Now, Web of Science doesn't have the same sources list, but Insights does. Insights, however, is a bit less pleasant to search. Always just go through this way to get there, because for whatever reason my login doesn't work with Insights if I go straight there. And that's taken a really long time. Oh, here we go. Okay, so Insights. While that's loading, if I wanted to search to see if my journal is indexed in Web of Science, okay, and I can see here that it is. Okay, Insights. Now, where do I go to do it here? Yeah, so you go into the journals, books and conferences, and then it's research area. And then you can go in by FOR code if you want. So let's go 0404, update results. And these are weird. Why is Lancet coming up?
Because I think you excluded.
I excluded it, yeah. Right. Thanks, Philippa. So yeah, don't do what I did and tick that box. You want it to stay on equals, press equals. And then, so these are the top journals as sorted at the moment by the time cited count. You can choose different ways. This list though is, it's not as friendly and it doesn't present as much information straight away as the Scopus list. I much prefer using the Scopus list for the journals, but you can look at different journal data within Insights. Righto, back to the presentation. So what is benchmarking and how can it help me? Benchmarking is basically comparing you to your colleagues, both here at the University of Sydney, across Australia and internationally. If you wanted to compare yourself to people you went to university with, you can. If you want to compare yourself to, you know, the top performing people in your subject area globally, you can do that as well. The best tool for doing this is SciVal. And the library, we can do most of this stuff for you. Some librarians, like myself, prefer or like doing benchmarking a lot more than some of the others, but there's a standard level of benchmarking that we can do. And then with negotiation, we can go beyond that. Other things that benchmarking can do is it can provide you with an indication about how you're standing compared to people who have had success with grants. So if you're going for a DECRA grant, for instance, we can run a benchmarking report comparing you to people who have been successful in DECRA in that FOR code across the last couple of years. So you can see where your track record is compared to that, to those people. And we can also do it with people who have achieved promotion within the University of Sydney to a certain level. If you wanted to see how you're sitting compared to colleagues who have achieved promotion. And the other thing that it can do is it can highlight where your numbers may be down slightly so that you can work on trying to improve that to improve your chances of grant success or promotion success. And I've mentioned the reports, and there are a few different ones that we can do. We have a base level metric report that we do that is a standard report. Every librarian will do this one for you. And then there's, as I've just mentioned, the benchmarking against the different categories of researchers, grant recipients and promotion successes. And we can help you out with strategic publishing strategies. So if you're having trouble wading through the insights and Scopus data, looking at journal titles to choose the best one to publish in, we can help you out with that. One of the people who is from the library here in this presentation, Vanna, is working on a strategic publishing guide that will become available at some point this year that will help with strategic publishing ideas and suggestions. And we can also help you explore the world of altmetrics, as such as it is. Anyway, this is the standard metrics report. This is a real report that I prepared last year for someone within the School of Geosciences. The first page that you get is just a brief introduction to the person's, on the left of the screen, we've got sort of what we've looked at. And then there's just a quick grab of what they've been, of their performance. So you can see here, we've got the publication count up the top, the citation counts across Scopus, Web of Science, Google Scholar, and you can see the variety of numbers that you're getting. So that's, 2/3 of the numbers in Web of Science as compared to Google Scholar. As I mentioned before, Google Scholar data is not particularly reliable. You could argue that Web of Science data for author level metrics as well is a bit patchy at times. Scopus is probably the most reliable numbers that we've got at the moment. Then we've got the citation per publication count. That Web of Science one looks wrong, but anyway, and then the H-index score. So again, your Google Scholar number is 6 times higher than Web of Science, and Scopus is 3 times higher than Web of Science. When I met with this person, I just told them to run with the Scopus numbers. The next page that we have, the next table, is derived from SciVal. SciVal is, as I've mentioned before, the best benchmarking tool that we've got. Here we're looking at the 3 FOR codes that this person primarily publishes in, and it's all fairly self-explanatory. You've got your straight up counts and your averages, and then you go into your normalized data. And then you've got your publication in the topmost journals down the bottom, and international collaboration. This is a benchmarking of the person, so under researcher outputs, comparing them to Australia and then comparing them to the world. And you can see here, if we look at the field weighted citation impact figures, that they're doing substantially better than Australia and global researchers in the same subject area. So, when I presented this report and met with the researcher, they were quite happy, as you should be. And then the final page that we have in the standard report is an entire career look at the top 10 papers that they've written. So we've got the publication details first, then the DOI, so that they can go back and just confirm the paper itself. And then we've got the citation counts, and then we've got article impact figures. So the field weighted citation impact for that article. And you can see that top one is ridiculously huge, nearly 20. And then we've got the percentiles appearing there. And you can see, if we just go down to the bottom there, you can see the 99th percentile in medicine. I can't recall exactly what journal that's from, but I'm suspecting that it's from Science or from Nature, which is a general database, general journal, sorry. It is Science, but it's because these are assigned by Scopus, that's why it's kind of giving this weird with subject area. This person's a geophysicist. They're not working in medicine or in history and philosophy of science. And yeah, the last two columns are JCR and SJR data. And that's just ranking the journal. So when they, and I've got a typo in that field there. This is, I prepared this report back when we were doing this all manually. We now get a machine to do it, or to do a lot of it. And then we do the enhancements on top of that. Anyway, that's the third table. If you get a metrics report prepared for you and you're after, you know, the last 5 years of work, or you want to highlight, you want journal data, sorry, article data on a particular set of, you know, 5 or 10 articles, talk to your librarian and we can pull this data out for you. Okay, and then from there, that previous one is the standard report. This stuff is the more, this is the stuff that you negotiate with your librarian to run for you. This one is benchmarking the person against other future fellows. And we can do this for basically any ARC grant. NHMRC stuff's a little bit trickier because it's not as readily, the database of grant recipients is not as easily interrogated to pull out a list of names. If you can provide us with a list of names of people that you want to be benchmarked against, we can do that for you. So if you have, you know, 10 people you know who are sort of working in the same area that you're working in, and started at around the same time, and you think you've got a fairly similar publishing profile, you can send that list to us and we can throw those names into Cybal and we can pull all this stuff out. So I'm not sure which row here is the person in question, but you can see that we've got it's all the same stuff that's in that table 2, but it's just against people who have received future fellowships within FOR 04, which is geology and geoscience. And you know, you can sort all of these fields, all of these columns, sorry, just to see how you're sitting against those people. And this one here, this is using insights data, and it's comparing the top, it is comparing the top people in Geo8 universities within an FOR code. I think it was 0404 again. And if we go through, there's a couple of universities of Sydney, there's about 4 or 5 there. And you can this is just a way to see where you sit compared to people that meet particular criteria. In this case, I think it was up to 50 articles that have been, and with a total amount of citations of like 750 to 1,500 or 3,000 or something like that, just to get kind of ballpark figures of people who had been working within that FOR code within the Geo8 universities. The last column over here, the category normalized citation impact, is just a Web of Science version of the field weighted citation impact kind of stuff. But they're all similar measures. They use similar types of calculations. The rule of thumb is with anything that's normalized, 1 is average. You want to be higher than 1, basically. Okay, and that's it for that part of things. I hope I covered everything. Just looking through my notes, I've gone through everything I've got. Did anyone have any questions?